Hey, on this video, we're going to go over the Introduction to Graphing Motion worksheet answers. So you can go ahead and check your answers quickly just using the answer key, but if you're looking for more of an explanation, then just keep watching. So question 1, what are the 3 types of motion graphs? So we've talked about all 3 of these now. The first one is a position time graph. The next type is a velocity time graph. Excuse my writing on this, it's not very good. And an acceleration time graph, and I'm going to abbreviate acceleration. All right, so position time graphs are also called displacement time graphs or distance time graphs as well. All right, so number 2, I'm not going to write this out, but why are motion graphs useful? If you look back into our first set of notes from this unit, you'll know that it's because there's a lot of information stored in just one picture, one graphic, compared to just us like describing a whole paragraph or page long description of what's going on. So it's just a they're useful because we just put a lot of information in one picture, to simply put it. All right, so moving on, position time graph section of the worksheet. So a position time graph represents the displacement of the object versus the time. What are the other names that you see for this graph? It can, I just mentioned, it can also be called a displacement time graph or a distance time graph. All right, I try to stick with just calling it a position graph, but you'll see it, sometimes labeled as those other things. All right, number 4, blank of the line tells you the velocity of the object at the time. You look back in your notes, you'll find that the slope of the line tells you the velocity. All right, so on a position graph, slope tells you velocity. Number 5, match the direction of travel to the slope. So if we want to move in the negative direction, we want a negatively sloping line. If we're moving in the positive direction, we want a positively sloping line. And if we're not moving, then we're going to have a slope of 0. All right, look back in your notes if you're still not sure about those. All right. Number 6, match the type of line to the type of motion. So this is the shape of the line. If we're not moving, we want to find a horizontal line. If we're accelerating, we're looking for curved lines. And if it's constant velocity, we're looking for diagonal lines. All right. So now let's sketch out some of those scenarios. So the first one here, moving at a constant velocity in the positive direction. So we know constant velocity is going to be diagonal and positive direction is going to need to go up. So our line can be a diagonal line going up. Now, technically speaking, it could be underneath the graph. It could be going through the graph, or through the x-axis rather. But we just need a diagonal line that is sloping upwards. Right? Constant velocity in the negative direction. Constant velocity means we want another diagonal line, and in the negative direction, we want a negatively slope. So it just needs a slope down. That should be a nice little diagonal. So it can be above the x-axis, it can go through it, it could be below it. Any of those 3 options would work. All right. Not moving. We said not moving. What kind of line do you want? You want a horizontal line. So we just want to draw a horizontal line. It could be above your x-axis, it could be on it, it could be below. It doesn't matter. Just based on this description, we just need a horizontal line. Right. Now moving into our accelerating scenario. So moving in the positive direction while slowing down. So positive direction means our line is going to be headed up on the graph. And we know slowing down is a curve that's going to get flatter. So we want to see a curve that's going up and getting flatter. All right. You could draw it above your x-axis. You could go below. You could go through. Again, the placement for right now on our graphs, just based on these descriptions, it doesn't matter where it's going on the graph. You're just looking for that shape. All right. All right, next one, moving in the negative direction while slowing down. So again, we want that curve that's getting flatter. This time we just want it to head down on the graph. So we're looking for a curve like that. And again, it can go underneath your graph if you want, or underneath your x-axis. All right, moving in the positive direction while speeding up. So we now are going to head up on the graph again, and we want to get steeper. So we're going to get a curve like this. All right, and again, it can go underneath if you want to. All right. And last one, moving in the negative direction while, it should say speeding up there, there's a typo. But speeding up in the negative direction should have a curve like that, or you could go underneath. So again, right, for this worksheet, all we're looking for is for things to match the description given. So there's different options that all of these match that description. All right, you only needed to draw one of them. But Anyway, let's move on. All right, next up is velocity time graphs. Velocity time graphs show you the velocity of the object versus the time. The slope of the line represents the acceleration, and I'm going to abbreviate acceleration of the object. And then we're going to match the type of line to the type of motion. So if you're accelerating, you are going to need a diagonal line. If you're going at a constant velocity, you need a horizontal line that is somewhere other than 0, meaning it's not sitting on the x-axis. And if it's not moving, you need that horizontal line that is at 0, all right? It's sitting at the x-axis. All right, then number 11, it's the area between the line and the x-axis that will tell you the displacement of the object, or simply telling you how far it's traveling during that period of time. So let's sketch these out, all right? For the first one, moving at a constant velocity in the positive direction. So on a velocity time graph, for positive direction, we need to be above the x-axis, and a constant velocity we just talked about was a horizontal line. So we would want, this is our option. It needs to be above your x-axis and horizontal. The second one, we're at constant velocity, but we're negative direction. So negative direction means we're below the x-axis. So we're going to draw it down here. If we're not moving, the only option for not moving is a horizontal line on the x-axis. And then the next one, moving in the positive direction while slowing down. So this is where it can get tricky for people. So we want positive direction, so that means we're above the x-axis, and we're slowing down, so we want to go towards the x-axis. So we want to approach 0 in the positive half of the graph, all right? If we're moving in the negative direction while slowing down, we want to be below the x-axis, but still approach 0. If we're moving in the positive direction while speeding up, we want to be above the x-axis and go away from 0. And if we're in the negative direction speeding up, we're going to be below the x-axis and speed up that way. So again, on the positive ones, all of these that say positive direction, notice that all of the lines are above your x-axis, okay? All of these are positive or above. The ones that say negative direction, your lines are always below your x-axis, okay? If the ones that say slowing down, your line's approaching 0 on those. And if it says speeding up, your line is going away from 0. 0 meaning the x-axis of 0, okay? All right, let's move on to the last bit, is acceleration graphs. And to me, these are honestly the easiest ones out of the three. So acceleration graphs represent, of course, the acceleration of the object. The area between the line and the x-axis is going to tell you the velocity. Right, what is the only type of line you'll see on acceleration graphs are horizontal lines. We don't have curves, we don't have diagonals. All right, so drawing things, if it's moving at a constant velocity, it's going to have to be a line with a 0 acceleration, meaning your line is sitting on your x-axis. Right? If it's got positive acceleration, then it's just a horizontal line in the positive half of the graph. If it's negative acceleration, it's below your x-axis, right? If it's not moving, it'll look a lot like the first graph, and it'll sit on the x-axis. So this first graph and this last graph, they're identical, and we don't have enough information. If I just give you this graph, then it could either be constant velocity or it could be not moving. We don't know enough information just on this picture to determine anything else. All we can tell is that it doesn't have any acceleration, right? All right, I hope this video helped. Please reach out if you have any questions.